This is Module M5B of the INDOT Certified Asphalt Lab Technician Program. And this section is entitled Asphalt Mixture Maximum Specific Gravity. So let's start off by defining what specific gravity is. Specific gravity is the ratio of the density of an object to the density of water. So for example, water weighs 62.4 pounds per cubic foot. A block of aggregate, let's say that we carved from a solid piece of rock that is exactly 1 foot by 1 foot by 1 foot, weighs 162.2 pounds, so it weighs 2.6 times more than the same volume of water. So as a result, we say its specific gravity is 2.6. Specific gravity is used as a bridge to convert mass or weight into volume as part of mix design. So let's look at the process of running a test to determine the maximum specific gravity of mix. And the method that's used in Indiana is called the bowl method. So the first thing that we do with the sample that we've split down is to separate the aggregate and the fine aggregate particles in the mixture until the conglomerations or the agglomerations of mix are no larger than 1/4 of an inch. And this is to ensure that there is no air that's trapped inside the particles of mix. We're going to place them in a bowl and we're going to weigh them. And that's going to give us the weight of the dry sample in air. Then we will cover the sample with water and we'll place it under vacuum for 15 minutes with agitation. After this time, then we release the vacuum and we weigh the bowl and the sample together under water. And that gives us the mass of the bowl and the mix in water. Then we will need to know the weight of the bowl itself, by itself, underwater. And that gives us B, the mass of the bowl in water. So here's a photograph of separating the fine aggregate. And of course, the rocks are going, there could be aggregate particles that are larger than 1/4 of an inch, but the key is the sand-sized particles to break them apart enough that there is no trapped air inside them. Then we take a dry weight of the sample. Here you can see it sitting on paper on top of the scale. We put it in a bowl and cover it with water, and this is done at 77 degrees. Here you can see the sample sitting underwater. And then we're going to vacuum that sample for 15 minutes with agitation. So yeah, the device with the blue handle there is the vacuum pump, and there's an air drying system that you see up on the shelf, and a pressure gauge on top of the lid that is held down, and the bowl and the lid and everything sits on top of an agitator, and it shakes the sample as it's being vacuumed. Here you can see what it looks like while it's under vacuum, and you can see that the water is bubbling. It's almost like the water is boiling. There's air that's coming out of the sample. Now, before we would have used the bowl, we would have determined what the tare weight of this bowl is underwater, with no sample in it, of course. Now, after this vacuum saturation, then we weigh the bowl and the sample underwater. And now we are ready to calculate the maximum specific gravity of the sample. So the items that we need, we don't need this 4.9% asphalt content. We do need the weight of the sample, which is shown here as being A, 2215.9. We will need to know the weight of the bowl underwater, which is the 1229.2. And we will need to know the weight of the bowl plus the sample underwater, which is the 2557. And here you can see the equation. It's the dry weight, or the weight in air, divided by the weight in air minus the weight underwater of the bowl plus sample, and then take away the weight of the bowl underwater. And if we plug those numbers into this equation, we find that the answer is 2.495. So we would say the maximum specific gravity of this sample is 2.495. So let's look at another example. So here we are not told what is the A, the B, and the C. We need to determine that from the information that's given to us. Now, once again, there's some extra information in here which is not needed, that being air voids. We need to know the weight of the sample in air. So where is that? Weight of the sample in air is right there, 2526.3. We need to know the weight of the sample and the bowl underwater. And there it is there, 2753.6. And then we will need to know the weight of the bowl underwater. And that is the 1228.2. So this weight of the bowl in air is extra information that we don't need. So this is A, this is C, and this is B. And so here we plug the numbers in, and we have the weight of the sample in air divided by the weight of the sample in the air minus the bowl and the sample underwater minus the weight of the bowl underwater. So we plug the numbers in and do the arithmetic, and here you can see the weight of the sample in the air, the weight of the sample in the air minus the weight of the bowl plus the sample underwater, and the weight of the bowl itself underwater. And we get an answer of 2.524. And so that takes us to the video that shows us how to do that.
So here I've got a GMM sample, and I'm going to spread this out to where it's less than 1/4 of an inch. And once it's cooled down, then I can go into further testing. So I've got my scale here, and I am going to tear out my pycnometer, and I'm going to place the cooled GMM sample into the pycnometer to get my dry weight. So once I've gotten the dry weight, I'm going to add water. That's 25 C or 77 degrees F, so that it's at least 1 inch above the sample. Now I'm going to place the pycnometer with the sample onto the vibrator, add the lid, close the lid top, set the sample up so that it is under vacuum for 15 minutes plus or minus 2 minutes, but we need to make sure that we are at our 25 to 30 millimeters of mercury before we start the time. After the 15 minutes, we'll slowly release the vacuum, remove the sample from the vibrator, and to check if there's any particles floating at the surface of the water. If there are, knock them down. Tare your scale and then place the sample with pycnometer into the water so that we can get a water weight. We'll set a timer for 10 minutes. After the 10 minutes, then we can record the water weight. Make sure to have your water in the overflowing position as noted here. After the 10 minutes, you can record your water weight and remove the pycnometer and sample. We're going to use this sample for a dryback, so I'm going to set this off to the side. I make sure to get all of the sample into a pan. To get our calibrated pycnometer weight, we'll set this in the water without a sample, just the pycnometer itself. Allow 10 minutes to pass and then take the weight. Going into the dryback procedure, we have a significant amount of water left over. If you have a lot, then you can remove this with a turkey baster or something to remove the water. Make sure that you don't lose any of the sample. I know the weight of the pan prior, and I know the weight of the sample that I've just taken. I'm going to put this in front of a fan for 15 minutes, and after the 15 minutes, then I can take another weight. And if the weight is within 0.05% of my previous taken weight, then I can record this as my final dryback GMM.